Okay, everybody, we're going to get started here with our Weather Basics class. My name is Eric Hayden. It's just about 10:30, and I know we had a lot of folks sign up. Given our current situation, we really appreciate people joining us. I know we have a lot of students and teachers on looking for some material. Just a brief background on this. This is something that we've done before via Google Hangouts. So we've done this to the classroom. So once we get back to normal, that's something we can certainly do where we do a presentation like this. The focus is fifth grade standards. I know some of you are older or younger. It's applicable really for everybody. So sit back and enjoy. A couple key features about this webinar. Number one, you can ask a question through the chat at any time. So ask those questions. If you're unclear about something, you can send that to us privately. Mike Lee is joining me from his home. So he is going to, I'll unmute your line there, Mike. He's going to join me and do the presentation, and we'll take your questions at the end itself. The other way you can ask a question, if you raise your hand at the end, and you do have a microphone like this, you can ask a question verbally. So you can certainly do that, and we'll save all the questions for the end. So the way it's going to work, this is about 45 minutes. I'm going to turn it over to Mike here pretty soon. He's going to go over some basic weather about who the Weather Service is and what we do. Then we're going to talk about cold fronts and warm fronts, high and low pressure, and the different seasons. I'll cover that part. Mike is going to end with weather safety, and then about the 45-minute mark, so roughly about 11:15, we'll take some questions from the audience via chat or audio. So Mike, if you're ready, I'm going to turn control over to you, and everybody sit back and enjoy. I appreciate everybody joining. Mike, you might see this, but we have about 116 people on, so a lot of folks joining us. If you know people that could not join us, I know it's nice weather here in Eastern North Carolina. We have classes scheduled through the end of March. So based on your feedback and based on the amount of people that are joining us, we'll probably be doing this again. So Mike, I'm going to turn control over to you.
Excellent.
And you should be all set. And I've got the audience view up, so I'll know how everything's looking.
Okay, awesome.
All right, we see you perfect, Mike.
All right, you see me perfect? You see the presentation and everything as well? Awesome, excellent. Hi, everybody. My name is Mike Lee. I'm a meteorologist here at the National Weather Service. I'm actually joining you from home. I mean, there's a lot of stuff going on in the realities of today. So I'm actually joining you from my living room. So I do apologize. I do have a dog, so if she starts barking, just try to ignore her, and I'll try to talk through that, all right? So again, I'm a meteorologist at the National Weather Service. What a meteorologist does, I mean, there's so many different roles that meteorologists have in our society. As a part of the National Weather Service, we're part of the federal government, and what we do here at the National Weather Service is, we're the ones that forecast the weather for you. We look at the forecast models, we take measurements, we issue warnings, and we issue advisories as well, in addition to other severe weather watches and warnings. And we'll go over all of that in a little bit, but some more commonly known roles as what a meteorologist does in our society is, I mean, you've seen folks on TV, folks at WITN or NCT, local meteorologists, national meteorologists. A lot of folks are on TV. And down here you can see someone using the green screen. That's a very common thing that the television meteorologists use. I used to work at a television studio myself. And I tell you what, you think maybe you can't really see the green screen, and you'll get it kind of a little bit weird trying to, position your hands in the right place with the green screen and trying to explain to folks, what the weather's going to be. But you do get used to it, and I know a lot of meteorologists and my fellow colleagues, they do enjoy communicating the weather to folks at home. So on top of that, we have great folks in the military that also work meteorology. I know that there's a couple of people over in Cherry Point. A couple of the Marines over there are focusing on meteorology, and they're the ones that issue forecasts and alerts for the base. And then there's also research and academia as well. I have some professors at the university I used to go to. They're the ones actively doing research. We have a lot of great universities right here in North Carolina that do invaluable research in weather. So we have folks at NC State, UNC, ECU. They do amazing work in the research aspect of meteorology. And some things that can be, some things that they do is they look at, the past weather events. They try to figure out, what exactly went on during these things. Sometimes these events can happen so quickly. They like to review a couple of things. Some other ones, they also like to do a little research. Down here in the bottom right-hand corner, you can see right there, that's what we call a Doppler on wheels. So they take a Doppler radar, they put it on a big truck, and they run it through into the Great Plains, and they try to get close to certain thunderstorms and tornadoes, so that way they can get some better data for the research. But of course, again, that's one of many things that meteorologists do in our society. Back to the Weather Service, we have 122 local offices around the nation, and that's on top of a national headquarters in Silver Springs, Maryland, as well as 4 other regional forecast offices, and then one office that focuses on severe weather, the SPC, Storm Prediction Center. They work in Norman, Oklahoma, and they're the ones that send out watches and warnings. So they send out severe weather watches to the entire United States. And then we also have hurricane centers in Florida as well as Hawaii. So in total, 122 offices locally. Our local office right here in Eastern North Carolina, we cover anywhere from Jacksonville up to Nags Head to Outer Banks area. Basically, as far east as you can go in Eastern North Carolina, and that's where we cover, in addition to any marine areas out from the land areas as well. So we do inland river sounds, adjacent oceans. We are also covered by our neighbor offices in Raleigh, Wilmington, as well as Wakefield up in Virginia. Those are our neighbors. We work very closely with them to make sure that the entire area of North Carolina is taken care of and protected from the weather. We are open 24/7, 365, year-round. Right now it's a leap year, so 366 days really, and we are open no matter what. We are there for you. We have folks in the forecast office right now, despite all that's going on right now in our lives. We have folks in the office. I'm personally at home, just trying to keep that social distancing going. But typically we have staff here, a staff of 2 or 3 people here all 7 days. And our building is designed to withstand storms. And whenever there's a hurricane or if there's a big weather event, we stay at the office because that thing is honestly a bunker. We've got hurricane shutters that will close over the windows that we have, so that way any flying debris that comes our way won't shatter the windows and compromise the building. And the building is able to withstand up to Category 3 hurricane strength winds, although we'll talk about flooding later, but that's a whole different story. But any type of storm that comes by, we will stay inside here. This is an awesome picture over here of the folks in the office during Hurricane Florence. Everyone was there. Even one of my friends, a little pup there, but you can see here, we will stay inside the building. We will stay inside. We will have food supplies, bedding as well to stay in the office 24/7, 365, no matter what happens there. Our work hours, again, we never close. So there's 2 to 3 forecasts per shift, and shifts range from midnight to the evening. We do have a management team. Those folks will stay here from 8 a.m. to 5 p.m. Monday through Friday. And in total, we have about 22 to 25 people working around the clock for you to make sure that the folks in Eastern North Carolina, as well as the rest of the country, have the forecasts and the warnings and protection that they need to go about their everyday lives. Our website is located at weather.gov/Newport. Weather.gov/Morehead City also works, but that is where you can find weather information from past events, current weather, and forecasts that we issue out. If you're not from this area, I know there's a lot of people that joined today, and I'm really glad that you guys are here with us. Folks that are not here in Eastern North Carolina, let's say you're from Oklahoma or Montana or anywhere else around the country, you can find your own local weather service office by just going to weather.gov and then clicking on the location that you have, or you can also enter it into the location bar up top here. You can explore this website, bookmark it, see what you like, and you can get in-depth as much as you need. Anytime there's a very significant weather event, we will post weather briefings on the top, and then you can go into those weather briefings and learn more about the storm and with an in-depth perspective from our end. We do issue a 7-day forecast. This is your standard 7-day forecast that you use to go about and do your business. You can learn about sky cover, high and low temperatures. Is it going to be really windy? Is it going to be really wet, or is it going to be really dry? You can find that out through our website. And again, you can get as detailed as you want to. You can go through different icons, just kind of glance. Oh, I just want to know what the high tomorrow is. I know it's going to be sunny, so the high tomorrow is going to be 60, 70, or 80. If you want to go more in depth, we do have a detailed forecast as well. You can scroll down and read more about the forecast really quick. We also have graphical forecasts. You can view those on a map. Those include marine forecasts. So, for instance, if you are a mariner, if you like to go out boating, you can get the wind and the wave heights from our website. You can easily access all of this weather across the region or state. And then you can also, again, go even more in depth. We will issue watches, warnings, and advisories for mariners out there. We will tell you if there's a small craft advisory. If folks with smaller ships and boats need to be concerned about the waves or winds, we will let you know about that. In addition, we'll tell you what the period is for the waves, where the winds are going, and everything you need to know in order to have a very safe trip out on the waters. Another thing that we do is aviation forecast. So I know flying right now is a little bit iffy, but when everyone starts flying again, we're the ones that do take care of a lot of the local and regional airports that send out planes and send you out off to your destination. We create what is called TAFs, or terminal aerodrome forecasts, and what that does is we tell them, okay, here's what the wind speeds, the wind direction, cloud heights, and visibility are for that area, for that airport. And if there's any concerns about thunderstorm threat or fog or anything that may impede your flight in and out, we also service folks that are private pilots. So anyone that just does piloting for recreation, or if it's just a little hobby of yours. My neighbor's actually a skydiver, so he actually does use our observations and our TAFs quite a bit. And any day that is a really nice day, he makes sure that we let folks go out, enjoy the nice weather, and have a nice and safe flight to the destination. And one more thing that we also do, and forecast-wise, is fire weather. Anytime that it's really dry, or if there's a drought going on, or there's just been no rainfall, some people think, oh, you guys have it easy right now. You don't have to worry about any hurricanes or thunderstorms or anything. That may be true, but at the same time, that's when we start having to worry about fire weather. So anytime there's a wildfire, or if a local forestry service wants to do a prescribed burn, we're the ones that provide that forecast to them, so that way they can do prescribed burns, make sure that it's not any bad conditions that are really good for wildfires, and we're the ones that make sure that those prescribed burns go well. In the event of a wildfire, we're the ones that communicate with the volunteer firefighters and the federal agencies to coordinate. All right, where do we think that these flames will start growing? Where what time when the winds will start picking up and start spreading the fire? I'm sure earlier this year there was some really bad wildfires down in Australia, and the National Weather Service actually did send some folks down under to help out with the wildfires down there. Those were what we call IMETs, and they're trained to actually be deployed to help out folks around the nation as well as around the world to fight fires. Scott Kennedy, right here in this photo right there, he's one of our IMETs here at the local office. He wasn't deployed in Australia, but he has been deployed before. So we're around here to not only help the local folks in Eastern North Carolina, but we're around to help the nation as well as the rest of the world. Here's a quick little look at our office. I know that a lot of folks, unfortunately, can't visit us right now, but our office is located in Newport. And if you ever drove down US 70 and you've seen this giant soccer ball in the air, that's us. That's our radar. That's what we use to see precipitation. And then inside here, these are workstations. And then we also have an upper air station as well. Again, we are open 24/7. Once we're able to allow tours, we will welcome you all to come visit us and say hello, and we can show you around. We can show you some really awesome stuff. Forecast-wise, it takes a lot of data to go inside our weather models to actually make the forecast, to actually see what's going on, and then create the forecast for you folks. And it actually all starts with just simple weather instruments: a thermometer to measure temperature, a wind vane to an anemometer to measure wind, a rain gauge to measure precipitation, a hydrometer to measure humidity, and a barometer to measure air pressure. All of that is collected among thousands of locations around the United States as well as around the globe. And all that takes a quick little snapshot of the weather conditions that are happening on the ground. All that information gets put into these weather models. We call those initial conditions. And what we do with that information is we start the weather model saying, here, here's your starting point. Now let's plug it into all these complex formulas and push it out. And let's see what the forecast does. Without good instruments and without good measurements on the ground, we would not be anywhere without these forecast models would not be able to go anywhere. So these measurements on the ground are very important to us. In addition to that, so stuff on the ground, that's great and all. We definitely need that. But if you look up in the air where the clouds are, we need measurements all the way up through different levels of the atmosphere. So everywhere that a plane goes, we have to measure everything because that's where all the clouds are. That's where all the weather happens. So there's no way for us to actually measure and use those weather instruments, up in the air, unless we have what we call a weather balloon. So these weather balloons, these will actually measure temperature, wind speed, direction, humidity, and pressure in the middle of the atmosphere for us. So that way we can get a full snapshot of the atmosphere. I like to think of the atmosphere as like a big cake, right? And if you folks like cake at home, I know I definitely do. You don't know what kind of cake you got until you slice it open. And that's what these weather balloons do. They slice open the atmosphere and let us take a quick peek inside what is going on inside the atmosphere. It's going to be hot, cold, wet, or dry. And with that information, we'll be able to tell you, all right, is there going to be thunderstorms today? Is it going to be a really nice day? All that information is definitely invaluable to us. And we wouldn't be anywhere without these weather balloons. They are launched twice a day across nearly 100 locations across the United States, as well as additional 300 locations across the world. They will all launch at the same time twice a day. And if you've ever tried to plan something with a bunch of your friends, you know for a fact that sometimes it can get a little difficult trying to plan things with everyone's different schedule. But we do it, and we stick to it. All 300 locations will try to launch twice a day, so that way we could get a quick snapshot of the atmosphere for our forecast models and for the forecast that we create for you guys. The next tool that we use is Doppler Radar. There's that big dome that I mentioned to you before. That's right along Highway 70, and if you're across the country elsewhere, you might have seen this at airports or your local forecast offices as well. And what these big domes do is that they house these very large antenna, pretty much just a very large satellite dish that just spins around and scans the entire atmosphere for rain, snow, hail, and even tornadoes. Our tornado warnings, we can't always see what's happening on the ground, but these Doppler radars are able to detect that little bit of rotation inside a thunderstorm that allows us to predict when a tornado is very likely to happen. That's when we issue tornado warnings. In addition to that, we also know when hail is going to start forming or showing up, as well as snow and rain. Honestly, Doppler radar is an invaluable tool for us when we make our watches and warnings. And then on the last tool that I'm going to mention here is weather satellites. You can see these weather satellites. They are they're in the atmosphere. They're in space. They are hovering over our country and our world, and they're just taking a snapshot of what's happening on the ground and in the atmosphere. You can see large clouds, large storm systems, whether it's been sunny or clear. You can also see hurricanes, those epic pictures of hurricanes that are on the ground in the ocean and impacting us. You can see from satellites, and we get a lot of data from these satellites, not just pictures of the actual clouds. We also get a lot of readings for our forecasts and for our forecast models. So some really great weather tools that we have here. I'm going to switch it over and hand this over now to Eric. He is going to chat more about weather basics and really get into the meat and potatoes of the presentation here.
Mike, excellent job. Mike is one of our newer forecasters here. Really appreciate him doing this. Again, we're doing our social distancing here at the Weather Service. Mike is at home. Hang on the line because we're getting into the meat and potatoes of the presentation that Mike mentioned, specifically cold fronts, warm fronts, low and high pressure, and then hang on for the very end, cross our fingers that the technology works. I've got the laptop set up in operations. We don't have a lot of staff here today, but we want to give you a virtual tour of the office. So I know we have 147 people on mic, so that's amazing. Hang tight. We've got a lot more to show you. I want to do a quick follow-up, Mike, and Mike, you can drop off the webcam if you need to, get a glass of water or anything, and then just hop back on whenever you feel that you want to. Mike will be back with us. He's going to do weather preparedness at the end. Before I get to my presentation, I want to follow up with what Mike was saying. A couple of resources, teachers and students, you all had an email that you used to sign up for this class. I will send you all these links, so don't think you have to jot it down. But I want to show you some of the resources available to you after this class is over with. First things first, YouTube. If you search NWS for National Weather Service, Morehead City, a lot of cool videos there. If you scroll down the page, Mike was mentioning the weather balloons. We have a 50-minute Facebook Live video where we go from A to Z on our balloon launch process. And then we have some shorter videos that are more 9 minutes or even a time lapse of the weather balloon. So if you want to learn more about the weather balloon, NWS Morehead City on YouTube, you can certainly do that. He mentioned the website, weather.gov. We have people from California, Michigan, New York State. So while we cover Eastern North Carolina, we have a lot of folks on this learning experience, and we really appreciate that. Just go to weather.gov, and he mentioned you can get your local forecast by clicking anywhere on the map. But the other thing I want to direct teachers and students to is scroll to the bottom of the page, weather.gov. Check out some of these links at the bottom. There's a lot of good information. First things first, he mentioned radar. So I've got the Doppler radar loaded up so you can see the radar all across the country. You can zoom in and show your students where the weather is happening. If you scroll to the bottom of the page and click on weather safety, that will take you to a page with lots of preparedness information. So kids, if you're doing a science experiment, a research paper, and you need to know more about hurricanes or thunderstorms, that's a good resource for you as well. So again, weather.gov, scroll to the bottom, check out some of these links. I will send these to you after the class is done, so don't feel like you're missing anything. We did get a couple questions in the chat. Will this be recorded? Cross fingers, we're recording it now. If it works out, we'll post it to YouTube, so the answer to that is yes. The last thing I want to show you is weather.gov/Owly. Owly Skywarn is our weather service mascot. We have a lot of folks in the local office, men and women, that are doing that forecast 24/7, but we also have a lot of folks at our headquarters in Silver Spring that are working on this type of content day in and day out. This has always been here, but we just want to make sure you know it's there as a resource. So under the weather science section, it's broken down to kids and teens and parents and teachers, and it will send you to certain links that are age appropriate. One of them is Jetstream, one of our online schools for weather. So I don't want to get off track too much with our presentation, but I did want to mention some of those resources, and we will send those to you after this class, so that will get you going. So Mike mentioned the meat and potatoes of the presentation. For those that are just joining us, and now this is the 5th grade weather standards. These are all things that you are going through, perhaps you already did in your class or will learn shortly, and that's why we wanted to cover it. And teachers, we like your feedback. If this is hitting all the standards that you need, that's great. Let us know. If we're missing anything, let us know that as well. So our weather really starts with the sun. And the reason for that is the sun heats our atmosphere and specifically our land areas differently. If you're closer to a body of water, it doesn't happen as efficiently. If you live on a mountain, you're cooler. So the sun heats the earth depending on where you are differently, and that plays a big role. Because the earth is heated differently, that's going to lead to something called pressure and wind, and we'll talk about that in a second. So this diagram is showing you that the sun itself actually heats the earth, the surface of the earth, and in turn, that warms the air above it. So if you look on the far left-hand part of the graphic, as you get higher in the atmosphere, you get colder. So if you've ever been on a plane, you might see frost on the plane itself. If you've ever been on a mountain, the higher you go, it usually gets colder. So that's important to remember, that the sun doesn't just heat the air, it actually heats the earth itself. And that's not equal all across our earth. And that's very, very important. We'll explain that in a second. So we know that our earth heats up differently because of differences in elevation, proximity to water. but it also heats up differently depending on the season. And I think it was just yesterday, Mike, I can't remember. It seems like everything's been a blur here this last week. Our first day of spring. So we have different seasons. When the Earth is not tilted toward or away from the sun, we call that the equinox. It's from the Latin term meaning equal day and night. In autumn, it's called the autumnal equinox. That's the first day of fall, usually about the third week of September. And then the vernal equinox is what we just had, the first day of spring, and it's usually about the third week of March. So again, these are seasonal differences. And when this happens, the Earth is not tilted toward or away from the sun. Gradually, as we head toward the month of May and then eventually June, in the northern hemisphere, our Earth is slowly tilting toward the sun. And about the third week of June, we have the first day of summer. That's called the summer solstice. And when that happens, the strongest sun angle is in the northern hemisphere. It's up toward the Tropic of Cancer. A few things to remember. The Earth is not heating up the same because the Earth is tilted differently depending on the season. So that's something you want to remember. The other thing I want you to remember is when we're the first day of summer here in the northern hemisphere, it's actually the first day of winter in the southern hemisphere. So it's always opposite. So whatever we are, it is going to be opposite in the southern hemisphere. So we slowly tilted the Earth toward the sun. Now we tilt it back toward even. That would be fall. And then now we start to go the other way. As we go toward the first day of winter, the Earth actually tilts away from the sun in the northern hemisphere. So when that happens, about the third week of December, that is the first day of winter. We call that the winter solstice. Again, about the third week of December. The highest sun angle then would be toward the southern hemisphere in the Tropic of Capricorn. And the important thing to remember is when it's the first day of winter in the southern hemisphere, it's the first day of summer here, or excuse me, when it's the first day of summer here, it's the first day of winter down in the southern hemisphere. It's always opposite. So please remember that. So in this case, we are winter. As this happens, the winter solstice, and the sun is angled higher in the southern hemisphere, so they are the first day of summer. So remember, it is always the opposites. I keep saying that because we're going to do some interactive quiz questions here in a minute that you'll have a chance to answer. So because the Earth heats up differently, differences in season, differences in elevation, differences in proximity to water, our Earth is heated differently, and that causes a difference in pressure. Notice all those symbols on the map. The H's are high pressure and the L's are low pressure. Because of the difference in pressure, that is what causes wind. So again, starts with the sun. We heat our Earth differently depending on season and where you are. And because of that, it causes a difference in pressure, and that causes the wind to flow. Air likes to move from high to low pressure. So you can see on this animation that our air flows from high to low pressure. And we're going to talk more about the differences between high and low pressure here in a second. So before we get that, I want to turn it over to you for a question. So if you're just joining us or just now paying attention, please look at the screen and think about what the answer is to this question. Because of the Earth's tilt, what do we get? Do we get number 1, day and night? Do we get 2, gravity? Do we get number 3, the seasons, winter, spring, summer, and fall? Or do we get number 4, the lunar cycle? We'll give you a second to answer that. And if everybody's yelling out number 3, the seasons, you are correct. Because of the change in the Earth's tilt, it gives us the seasons. If it's not tilted toward the sun, it's equal. It's either spring or fall. If it's tilted toward the sun, we are summer. If it's away, it's winter in our hemisphere. All right, second question. You should get this one. When it's summer in the northern hemisphere, so where we live, what season is it in the southern hemisphere? So again, we're summer. We're headed towards summertime now. So what's going to happen in Australia and South America? What season will it be? Will it be summer? Will it be the same? Will it be winter, the opposite? Will it be fall, or will it be spring? And if you answered number 2, good job. And you can answer those in the chat feature. I encourage students to do that so that we can see your answers. And the correct one for that is winter. So very, very good job with that one. So that moves us on to high and low pressure. We're going to talk about fronts coming up, and then I'm going to turn it back to Mike for some weather preparedness, and then again stick on our call for our virtual tour of the office. High pressure, it's on the map as a blue H. We like to think of happy weather, and that's because the air descends in an area of high pressure. It actually sinks. So this is good weather. If you want to go on vacation, you want to go to the beach, it's usually clear and sunny. It doesn't have a big relation to is it hot or cold. It's more about being nice out because of that falling air. And so think of high pressure as happy weather. The opposite of that is low pressure. It's on the map as a red L. And then we associate that with lousy weather. And the reason for that, if you look on the diagram, the air actually rises. It's forced to rise in an area of low pressure. So clouds are more likely, rain, snow if it's cold enough. A hurricane is an intense area of low pressure. So again, lousy weather with low pressure. So if you're looking at a map, you want blue H's if you want to have nice weather, and low pressure would be bad weather. So please keep that in mind. A couple other things on a weather map are fronts, warm and cold fronts, and the upper left is an example of a cold front. It will be on the map as a blue line and triangle. So use your colors to identify it. Blue is a colder color, so that means colder air is coming in. Notice those triangles are pointed to the right in this diagram. The triangles always point where they're going. So that shows you where the front's moving. Behind the front is cold air. And on that diagram, you can see that cold air is very dense, so it pushes ahead, and it causes showers and thunderstorms right along the front itself. So a couple key features: cold front brings in colder air. Right along the front are showers and thunderstorms. Now, a warm front is opposite. It's marked by a red line with half semicircles that are filled in. Those semicircles also point where the front's moving. So again, wherever those are pointed is where it's moving. The big difference with the warm front is behind it, instead of cold air, you have warm air. That warm air is very light. So the cold air that's in place, it rises above it, and it causes some showers. It could cause some thunderstorms, but it's a much more shallow feature. So you don't tend to have those real tall clouds that you do with thunderstorms. So this is a map down toward Texas, and I want to thank our friends down in the El Paso office. Tim Bryce is a forecaster down there. He's been doing this type of presentation for a long, long time, and he has a team of meteorologists that do this all over the country. So he started this Weather Basics. Really appreciate him doing this. And again, we usually do this as a Google Hangout via the classroom. So teachers, when we get back to normal, keep us in mind. We can do the same thing for your classroom and do an interaction lesson. So Tim created this graphic. Again, the blue line with triangles is the cold front. Notice behind it is cold air. The red line with the semicircles is the warm front. Behind that is the warm air. Where would I see, in the chat, I want to see you answer this question. Where would I see the showers and thunderstorms? Would I see it by the red L, or would I see the showers and thunderstorms by the blue H? So kind of think about that one. Where would I see the showers and thunderstorms on this map? All right, a couple more things, and we're going to turn it over to you, Mike, so you can be prepared. The jet stream, those are very strong winds high up in the atmosphere. They control our weather. They usually go from west to east. North of the jet stream is usually colder weather. South of the jet stream is warmer weather. So if you want a winter storm here in eastern North Carolina, you want that jet stream to go to our south and provide cold weather. If you're done with the winter weather, you want that jet stream really far to the north up toward Canada so we can get into some warm weather. There are different types of jet streams, and this is where you want to use your words on any tests. There's a polar jet. As you might imagine, the word polar, it's a cold jet stream. Subtropical jet, that's a warmer type of jet stream that can bring warm, moist air from the equator up our way. So if you have any testing and they ask about the different types of jet streams, use that first word in front of it to distinguish what type of weather it brings. We also have ocean currents. So we talked about the jet stream. We're talking high up in the atmosphere. Ocean currents transport ocean's warm or cold temperatures throughout the oceans. And this really keeps some climates much warmer than they otherwise would be. The one I'll focus on is the Gulf Stream. It starts down in the Gulf of Mexico, goes around the bend of Florida. And for us here in eastern North Carolina, a lot of fishing in our area because the Gulf Stream is only about 20 to 25 miles offshore. If you go there, the water is at least 70 degrees even in the wintertime, while we might be in the 40s and 50s. But that Gulf Stream doesn't stop there. It actually goes all the way toward Norway and England, and that keeps those folks much warmer, even though they're much farther north latitude. Because of that warm conveyor belt of water, it keeps them warmer. So on that picture of the globe, you can see there's warm currents and cold currents, and that transports that ocean's temperature all over the globe. One of the last things I'm going to talk about is the water cycle. When we get back to normal, we usually bring a cloud chart and a picture of the water cycle to school, so certainly look out for that. The water cycle and water in general is really an amazing molecule. It's the only substance on Earth that can exist in all three states: solid, liquid, and gas. So a solid would be a snowflake. Liquid would be maybe some raindrops, showers, drizzle. And gas would be, let's say we have rain, you have that puddle in your driveway or your parking lot, and then it just disappears. Well, we know it doesn't disappear. It actually transforms, it evaporates into a gas. So that's a form of gas. And the water cycle is endless. It continues. You can start anywhere on this cycle, and it will move right on through. So we'll start in the upper right as precipitation falls. Again, it can be rain or snow or hail that falls on the Earth's surface. Some of it runs off. It runs off into our streams and lakes and oceans. Some of it is absorbed into the ground, and we call that groundwater. So a lot of our drinking water comes from that. Some on the surface evaporates from the oceans and lakes or our parking lots, and it goes back up into the air. If we get enough of the water vapor, it condensates into clouds, and the cycle begins again. And we also get some moisture from the trees themselves through a process called transpiration. So a couple questions, and we're going to turn it over to Mike. The most common type of weather associated with high pressure is, and again, use your chat feature to answer. Let's see. And let's try something a little different. I'm up for different, Mike. So let's try something different. So I want folks to raise their hand if they know this answer. If you're going to raise your hand, make sure you have a microphone, an iPad, iPhone, anything with a microphone feature is fine. So the question is, the most common type of weather associated with high pressure, is it cloudy skies, gusty winds, sunny skies, or thunderstorms? If you think you know the answer and you have a microphone, raise your hand, and I'll call on you and unmute your line. So let's see here. And again, if you don't have a microphone, that's okay. You can participate through chat. We're just trying out some different features. So I'm going to call on Madison. It says Madison Upton. She has got her hand raised, so I'm going to unmute your line. All right, Madison, are you with us?
Yes, sir.
All right. So Madison, the most common type of weather associated with high pressure, which one do you think it is, Madison?
Gusty winds.
Gusty winds. We can have gusty winds with high pressure. That's very, very close, Madison. Thank you. That is very close. I'm going to call on, let's see, Lucas Green. So Madison said gusty winds with high pressure. That can certainly happen. What do you think it is, Lucas?
Sunny skies.
Lucas, very good. So Madison said gusty winds, and we can have gusty winds with it. And the one we're looking for is sunny skies. So Lucas Green, great job with that. I appreciate Lucas and Madison answering those questions. I think, Mike, we'll use that as our way to be interactive. So that's fantastic. Very, very good job. All right, we'll try another one. The most vigorous type of weather, thunderstorms occur with what kind of front? This is tricky because I just briefly went over this. So let's see what you think about this. I'll give you one hint. I did mention on cold fronts that they have dense air that pushes that air very abruptly. Warm fronts, it's much more shallow. And we didn't talk about occluded fronts. So use your process of elimination. What do you think that one is? Is it warm front, cold front, occluded front, or none of the above? Take a chance of that. Let's see here. I'm just looking through the chat feature and see if we can call on somebody different. All right. All right, we got Dylan Franklin. We're going to unmute your line. So Dylan, are you with us?
Yeah.
All right. All right, Dylan, what do you think it is? The most vigorous weather, like thunderstorms, which one of those do you think it occurs with?
Warm front.
Warm front, you can have showers and thunderstorms, so that we can have that, but we're looking for one other front, and I know I didn't go over this as much, so we're going to try Danielle Benton. What do you think, Danielle?
Cold front.
Danielle, very, very good job. Awesome job. So you can have showers and thunderstorms with warm fronts, but they tend to be more vigorous with cold fronts, and that's because that dense air really pushes the air up abruptly. So outstanding job. So at this point, I'm going to exit out of my presentation. I'm going to share the screen with Mike. So Mike, you can just turn your mic back on. I'm going to make you presenter.
Awesome.
So Mike, and just for a time check, because I probably went a little long, we're at about the 40-minute mark. So if you could take us home pretty quickly with the next couple slides, then we'll stay on track.
Okay, you got it.
Mike's
Awesome.
going to talk about weather safety. Mike, I'm going to hop off. I'm going to turn my webcam and my microphone off. Kids, students, parents, listen to Mike's preparedness tips, but we have a pretty good treat for you. I'm going to go outside my office. I'm going to show you the operational area at the Weather Service. So about 5 minutes or so, if not less, Mike, and I'll join you in our operations area. Good job with the first part, and fire away, Mike.
All right, awesome. Well, thanks for answering those questions, you guys. That was some good stuff. I'm hoping you guys are learning some stuff from this presentation. The last bit of stuff I want to go over with you all is some weather safety tips. And number one on my list is rip currents. I know that you guys are at home. You guys want to go to the beach. It's starting to get warm out in the summertime. Hopefully, we'll be able to get out and enjoy the nice weather. But there's something that's really important. And if you like the beach as much as I do, you're going to be there pretty often. And the number one concern at the beach right now is rip currents. And what a rip current is powerful currents of water moving away from the shore. They're not going to pull you down. They're not going to, try to, tumble you around. They're just going to pull you away from shore. They can sweep even the strongest swimmer away from the shore, right? Olympic swimmers can't even outswim this thing here. So it's very important that we follow these safety tips. If you get caught in a rip current, number one, don't fight the current. So if you're going to go out in the water and you get into a rip current, what's going to happen is you're going to be just taken out into the ocean. Do not fight the current. Don't try to swim right back to the beach. That's the wrong way to go. That's the trickery of this whole thing, right? You can't do any of that. You want to make sure that you stay safe. What you want to do is you actually want to, and you can follow these tips right here on this right side here, is you want to fight out. You want to swim out of the current. So swim parallel to the shore and then back in. Like that. You want to go pretty much in a circle. So if you get pulled out, you want to swim to the right or the left and then swim back in once you get out of the current. If you're not a good swimmer, I'm an okay swimmer. I really don't think I can actually get myself. I don't think I do a very good job with it. But if you're not a good swimmer or if you're feeling really tired that day, the next thing that you can do is you can wave for help and yell. So either swim parallel to the shore or float, wave, and yell. Those are the two things you can do. If you're not a good swimmer like me, you're just going to make sure you float, lay on your back, float out there, and just scream, hey, I need some help. I need some help. And if you're on the shore and you see someone that does need some help, make sure you don't jump out in after them, all right? You want to make sure that you get some help for them, call 911, get a lifeguard, and then if you have a flotation device, if there's something out there, you can go ahead and throw that to them. But you never want to jump in there after yourself. We still do see a lot of issues
Turn off the sound, please.
That have try to rescue others. So that's really important. Some other tips that we can do, and you can stay safe, is number one, you can swim near a lifeguard. So make sure that the beach that you go to has a lifeguard. So in case you do need help, there's someone right there right away. And even if you don't even know you need help, they can spot when you're in trouble, and they can pop out there and help you out. And again, never swim alone, and also never swim near piers and jetties, because if you swim near piers, you will have a higher chance of forcing insurance and stuff. I'm going to move on to some air safety.
You need to get it up. You know that?
So anytime there's severe weather, you want to make sure that you are safe in your homes. If you want to seek shelter, you want to make sure you find the best place for it. So anytime we issue a tornado warning and we ask you to seek shelter, the best place to go, number one, is down towards the basement. So down here in the basement of your household is the safest place to be. That all of our studies, all of our surveys have concluded that the closest to the ground you can get, if you get underground, that's the safest place to go. If you don't have a basement, I don't have a basement, so if you don't have a basement, think for a second now. Where is the most interior room on the lowest floor of your house? So on the first floor, where is the room that is most interior? So it could be a hallway, it could be a stairwell, it could be a closet, it could be a bathroom. You want to make sure that this room doesn't have any windows. It doesn't have that it's not right next to the outside wall. You want to make sure it's as interior as possible. And I know that's sometimes a little bit difficult for some folks. The home that I grew up in didn't really have a really good interior room. We did have a closet that could be used as a shelter. We could use the bathroom. Those will probably be the best places you go. Again, you try to cross everything off the list. You want to try and avoid the windows. You want to try and avoid a door to the outside. You want to try and avoid the outside wall. And you want to make sure it's on the lowest level possible. So think about that for a second. It's really important to know which room that you're in there and which room to seek shelter in if you do need to hide from a tornado. Really quickly, mobile homes are not safe during high winds and not safe during tornado as well. If you have time, the best thing to do is find a sturdy shelter and stay inside an actual home versus a mobile home or a manufactured home. Then a couple of more things I want to touch upon. Lightning, if you're playing outside, you're in the park, you're watching some baseball, you're outside on the beach. If you hear thunder, if you know there's going to be thunderstorms that day and you hear thunder, make sure you go indoors right away. With thunder roars, go indoors. That is the saying that we always tell people. If you can hear thunder, you can be hit by lightning. It doesn't matter if it's raining there right now. It doesn't matter if the thunderstorm is right on top of you. If you can hear the thunder, you can be hit by the thunder. Lightning can strike up to 10 miles away, so you can be in harm's way as long as you hear the thunder. And then once the thunderstorm passes, wait 30 minutes from the last time you heard the last clap of thunder or roar of thunder to go back outside. That's just in case, because if you wait 30 minutes, at least the storm will finally move away and won't be at risk to you anymore. Hurricanes, we're very familiar with that here in Eastern North Carolina. We get one every couple of years or every year or so. They are some really crazy storms. They're actually named differently across the entire world. So here in the Atlantic Ocean, so folks on North Carolina, Florida, the Gulf of Mexico, and in the Caribbean, the Bahamas, we know these as hurricanes. So we also know them as hurricanes in the Central and Eastern Pacific Ocean. So Hawaii, folks in Mexico, folks over in the West Coast, we recognize those as hurricanes. Then we pop over to the Western Pacific. So places in Japan, in China, in the Philippines, those storms up there are known as typhoons. Down in Australia, our friends down under, they always like to name something funny, right? We call those willy willies down there, and then in the Indian Ocean along the coast of Africa, as well as the coast of India and the Middle East, they're known as just tropical cyclones. So they're all different names, but they're the exact same storm. We just name them differently across the world. The way they work is that they're fueled by warm ocean water. So more than 80 degrees Fahrenheit, the warm ocean waters, it gets so warm up there, there's a lot of water vapor that just gets evaporated and starts creating these clouds. And there's a lot of clouds. And the more clouds we start building in, the bigger the storm gets. And as it gets bigger and more organized, that's when it starts to rotate and become a hurricane that we know as here in the Atlantic Ocean. So moisture rises, it condenses, it comes in the clouds, and then it starts, creating that low pressure that that Eric was talking about. And these are really, really concentrated low pressure systems. They're very concentrated. They're really strong as well. One thing that hurricanes can bring to our area, doesn't matter if you're along the coast, doesn't matter if you're inland or anything, doesn't matter what category it is, flooding. Hurricanes, storm systems, flooding is the #1 killer in the United States as far as weather events go. Flooding will it's more deadly than lightning, it's more deadly than tornadoes. It is very unfortunate, and it only takes 6 inches of water to swiftly move an adult off his or her feet. Never walk into floodwaters. Always turn around when there's a road flood and don't drown. That's what we always tell people. When flooded, turn around, don't drown, don't walk into the water, don't drive through the water. You don't know how deep it is, and it only takes 6 inches of water to sweep someone off their feet. The last thing I want to touch upon is weather and climate. A lot of people sometimes get confused with this, and that's all right. Weather, it happens, is the weather that happens at a particular time and place, so something that happens today, tomorrow, the next day, the next 7 days. Climate is a regional thing, so folks in eastern North Carolina or the southeast or the United States, it's a long-term thing. And the way I like to explain to people is that weather is the mood you're in today, and climate is your personality. So let's say, I think myself as a pretty bubbly person, pretty excited. That's my character. That's the climate, right? That's how I am. That's my character. But if I have a bad day, or if I'm get off the wrong side of the bed, or things just don't go right, and I'm having a really bad day, and I'm just really grumpy, that's just one particular day. That's my mood, right? That's what the weather is like. Your mood can shift throughout a day by day, but the climate can, what your characteristics are, what who you describe yourself as, that's what the climate is, and that's what we describe the weather as and the climate as well. So the weather is right now, and the climate is what what you've been in the past. So right now I'm going to go ahead and hand it over to Eric. I think he's ready. Eric, are you ready for a tour? Are you here with me?
I am.
Eric is with us.
Yep.
Excellent.
See what happens if you stop sharing your screen, if it makes us full screen.
Okay. Let's see.
I'm curious. It does, I think.
Excellent.
So at least, so what we're going to do here is we're going to take a tour of operations. You can drop off if you need to, Mike, webcam-wise. It doesn't matter to me. But what we're going to do is we're going to do a quick tour of operations. Mike, definitely stay on the line, though. Once I go back into the office, I'll field some questions because that's the only way we can see the questions. So here I am in the operations area, just about 20, 25 feet from my office. So my office was down there where we're doing the presentation itself. What we wanted to show you is the operations area. Much quieter today given our situation. We are staffed for emergencies, so on a quiet weather day when not a lot is going on, we just don't have a lot of people here. So today is a quiet day. We're doing our social distancing by only having a few employees here, just 2 right now, and we're going to talk to them on what they're working on. But before we do that, there's Tony. One thing I wanted to mention was we ramp up for emergencies. So if you were to come in here during Florence, or let's say we have severe weather this week, we're not going to be understaffed. We're going to bring people in, and we're going to take care of what's going on weather-wise. So as we mentioned in the beginning, our main mission is protection of life and property. We're open 24/7 no matter what. So we've kind of bared it down to the essentials, right, Tony?
Yes.
And you worked on something a little bit different this morning. Tony, I showed them a video, or at least access to video, on the weather balloon. So can you talk a little bit about what you did? You had to get in early this morning,
Yes.
did you?
Came in this morning at 6 o'clock in the morning to release the balloon. Actually, at 6 o'clock to release at 7 o'clock in the morning. Around 8 o'clock in the morning is 12Z, and that's when all the data comes in for most of the stations around the world. So we release at 7 o'clock in the morning, and so does the rest of the stations throughout the country. About 100 stations around the country that release about that time, and I'm not sure exactly how many around the world, but there's just the rest of the world does it at the exact same time. As Mike was saying earlier today, all that data comes in at the same time. We get a snapshot in time of what the atmosphere is like. Basically, we get temperature, relative humidity, wind direction and wind speed, and pressure. Just to give you an idea, this morning the balloon went up to about 105,000 feet. Here's the the distance in meters, so it's 32,000 meters, and it reached about 105,000 feet. The pressure at termination was 8.5 millibars, and to give you an idea, we are currently 1,024 millibars of pressure here at the atmosphere, and by the time it popped, it was 8.5, so that's how much the balloon went up in the air. So it moves about 1,000 feet per minute, and it goes pretty quickly. So it reached 105,000 this morning. That's when the balloon just couldn't stretch anymore, and the elastics on the latex just couldn't take it anymore and popped. We fill our balloons here in the station with hydrogen. We used to do it with helium. Helium is a very expensive gas and a finite resource. So we're now going to hydrogen, and we have so many safeties in order to fill the balloon. So all of those things are taken into consideration as we do this.
I appreciate it, Tony. It's an important job. Given our current situation, we're still doing balloon launches. The other situation, we do this twice a day, as Tony mentioned. During Hurricane Florence, we are launching balloons. The only time we cannot launch a balloon is if there's lightning nearby. So high winds, rainfall, we're still out there in the midst of the weather. And the reason why Tony and others are doing that twice a day, not only over our country, but all over the world, all that data goes into our computer models. Unless we had data, wind speed, temperature, not just for where we live at the surface, but high up in the atmosphere, we would not be able to make a forecast. So it's very, very important that we continue to do balloon launches. Now, what about the weather? Weather still goes on. You need to, know, is it going to be nice out today? And speaking of that, we had 147 people join us today. That's remarkable. Here in Eastern North Carolina, it's 75 out. Nice day, so I know you can play in your yard and stuff like that. So we appreciate you joining us for this virtual tour. So we only have one forecaster in today, and that's because, again, the weather is not active. If we get thunderstorms, if we're concerned with severe weather, we will certainly increase the staffing. But right now, the weather's quiet, so it's all on you, right, Morgan? Morgan is the forecaster today. Usually there's multiple forecasters, but with the weather being quiet, we just have one. So what's your job? I mean, you're responsible for 7 days. We told the students that we do an aviation forecast. So what are you working on today? What are you concerned with or looking at?
Well, yeah, as Eric said, normally we'd have two forecasters in here today, and one person would be focusing just on the first day and a half, and then the other person would be looking all the way out to day 8. Since I'm the only person here, I'm looking at all 7 days. We try to put our most detail into the short term, and we have the best idea of what's currently happening. As Eric talked about initial conditions and the importance of observations. The biggest story we're dealing with today is how warm it's going to get today. It looks like we'll probably have record high temperatures in a few areas for at least a few spots today as we crawl into the 80s, maybe a few upper 80s, depending on how much sun we get today. And then we have a cold front coming through tonight, more tomorrow morning, and as that comes through, we'll start to get some shower activity, maybe a thunderstorm or two. I'm still looking at that part of the forecast, just one of the many data sets that we look at. And then on the boating front, that we talked about our marine interests, this front's really going to be causing havoc out in the water. If we're going to have a lot of wind out there and a lot of waves, that'll make it hazardous for folks with smaller boats. So when we do a forecast like this, there's, we have the public in mind, but we have the marine interest in mind, or emergency managers who might be concerned about flooding or fire or anything along those lines. And then I also have to get the aviation forecast out by 2 p.m. for all the pilots around the area. So there's multiple audiences that I'm catering this forecast to. So the more detail you can add, the better the forecast is going to be, and the more valuable it is for folks like you or all of our pilots and whatnot.
All right, Mac. Well, we don't want to keep him too busy because he's doing the whole forecast today. Before we turn it over to you, Mike, just be ready to kind of pull your presentation up and do the transition while I log on to the other machine. I just want to show you, what Morgan, is in front of. Lots of computers. The one computer on the far side that I'm showing you now is an observational computer. It shows us current temperatures, wind speed. The one in the middle, Mike mentioned satellite. So right now Morgan is looking at the satellite. He can load radar, any current information he wants. Then the far computer he's working on now is called GFE. This is where we actually hand draw the forecast, wind speed, dew point, precipitation. So being a meteorologist certainly involves a lot of computers. And then Morgan does an excellent job with his forecast preparation. So on his PC, he's got model information. He's looking at current wind speeds on the one monitor on your left. And on the right, he's looking at a model projection for rainfall and thunderstorms coming in, over the next 24 hours. So hopefully you enjoyed the virtual tour. Again, it's a little bit different today, just not as much staff. But really, if you came to visit us on the weekend, on a holiday, it would be staff similar. So we're just low staffing because the weather is quiet. I'll last leave you with a wider perspective. This is the whole office itself. So I don't know how well you can gather. I'll kind of go from left to right. So there's Tony's workstation. We've got 1, 2, 3, 4, 5, 6, 7. So 7 people can be in here forecasting the weather during something like Florence or a big weather situation. And that's not showing the men and women behind the forecast. We have people that do computers in our office to make sure, look at all those monitors and computers we have. That's all running. We have people that fix the radar. They fix the weather stations. So you're not seeing a lot of the people that are usually at work today because of our situation, and the weather's quiet, so we don't need a lot of people in here, so we just don't have a lot of people in here. So at this time, Mike, if you could turn your webcam back on, and if you could share your screen, I'm going to hop into the office. It'll just take me about 30 seconds. I got to log into my office PC, so I'm going to drop off, folks. Please stay on the line, because what we're going to do now is it's your turn. We're about 11:30, so we're about an hour. So if you need to drop off, that's perfectly fine. The presentation is done. You saw the virtual tour. You saw the presentation itself. But we still have about 118 of you on the line. Ask questions through chat. Raise your hand, and we'll try to get to you with your questions through chat or the raised hand feature. We'll take questions maybe about 10 minutes or so, and then we'll go from there. So I see Mike's got a question for you. You can answer in the chat or by raising your hand. I will be back with you in about 30 seconds.
There we go. Now I'm muted. All right, folks. Well, now that while we wait for Eric to join us again, I'm going to ask you a couple of questions just to see what you guys were able to gain from the presentation, just to test your knowledge. If you're not in school, but guess what? You're still going to get a quiz, folks. Okay. All right. Number 1, what is the fuel source for a hurricane? Is it number 1, warm ocean water? Number 2, a peanut butter and jelly sandwich? Number 3, rotation of the Earth? Or number 4, cold ocean water? Now, you guys, I'm just going to have to make sure, you guys going to just use the honor system. I'm not able to see any hand raises. Oh, hey, Eric, how's it going?
Hey, so I'm back, so I can do it. So I've got Mike's question. You said, what's the fuel source for a hurricane? We've got warm ocean water, PB&J. That sounds good right about now. So raise your hand, answer the question. We'll do it that way. So let's see here. Let's see. Trying to make sure I don't call on the same person. All right. All right. So we've got Nico Fontana. So Nico, I'm going to unmute your microphone. So Nico, are you with us?
Yes.
All right, Nico. What do you think? What do you think is the fuel source for a hurricane?
Number 1, warm ocean water.
Awesome. Nico, excellent job. You can just advance it, Mike. So if you were playing along at home, very, very good. Warm ocean water is it. So that's very good. So he's got one more. You can read that off, Mike, and I'll do the question part.
All right. This one is a true or false question. Climate is the average weather in a region over many years. True or false?
All right. We'll see who we got here. So I see Parker Mason has his hand raised, so we'll unmute your line. Parker, are you with us? Climate's the average weather let me move my window, in a region over many years. What do you think, Parker?
I think it's true.
And you are correct. Very good, Parker. So the climate is the average weather over a long period of time. So I know we still have a lot of folks on. Teachers, if hopefully this met the 5th grade needs, let us know how the curriculum was. So at this point, we could probably go on a long, long time. I don't want to stretch it out too much. So it's about 11:35. We'll say 10 minutes of questions. I'm going to look in the question chat room now so that we don't leave those folks out. So I'm going to look through the questions and we'll answer them as they come in. So if you asked a question, kind of bear with us. We will get to your questions as we can. So let's see here.